So I'm Daniel van Strien, and I'm working as a digital curator on the Living with Machines project, which is a digital history project, which is kind of based at the BL and is a collaboration between the British Library and the Alan Turing Institute and a bunch of partner universities. And I'll talk about that project a little bit more later. But yeah, my role on that project is kind of, it's a little bit vague, but part of it is to try and develop training materials and deliver workshops like this, which are kind of based on some of the methods being developed or used by that project, with the goal of kind of making those methods more accessible to other researchers. And I guess there's a particular focus on making the methods more accessible to humanities researchers and people working in the GLAM sector. So that's galleries, libraries, archives, and museums. So I have this, I think, wildly ambitious schedule that is probably going to go off the rails very quickly, but I'm hoping it's not, too bad. I've got fairly quick intro slides, and then I'll kind of get to the more hands-on part. So yeah, just a very kind of quick overview of what I'd kind of aimed for today. So yeah, as I mentioned before, the focus of this workshop is particularly on using computer vision in a kind of humanities setting. But I'm hoping that for those who aren't from that background, this will still be useful. And I guess the kind of the aim is to really introduce this topic at quite a high level. So there's a few notebooks that we'll kind of work through, and they will kind of cover the pipeline of doing computer vision to classify images, but it will be at quite a high level. So I think there will be lots of parts that aren't properly addressed. But my aim with that is to kind of give an overview that hopefully gives you a sense of the steps that are involved. And then I guess the other aim that I hope to achieve is, if you're not already kind of using computer vision in your work, this will hopefully give you a sense of whether it's something that might be useful for you, and kind of provide a starting point for exploring this topic in more depth. So I guess the kind of flip side to that is there's a disclaimer that you're not going to know computer vision by the end of this session. The other thing is, I do have a question in the document about how much people know Python. So I think originally you kind of asked people for Python background, but I know that probably not everyone will have that. So what I would say is, I'll kind of get people to fill out the question about how much Python knowledge they have, but it's not kind of necessary to follow all of the code because it's at quite a high level. So what I'll try and do is explain what's going on. So some of the kind of Python bits don't make sense. Hopefully the kind of process that is underneath that will still hopefully be understandable. And then the other thing is that this material is based on a lesson which is still kind of being developed. So it is a work in progress. And if you have any kind of feedback at the end, it would be really useful for me and the other people working on this lesson to get that feedback and see how we can improve this further. So I'll give a very quick overview of some of these topics, and basically this is just me copying and pasting from Wikipedia. So computer vision, I think probably most of you will have a rough sense of what that is, but essentially it's trying to get computers to work with images in some ways. And more that's being done through machine learning, but computer vision as a kind of field is kind of much broader than that, and it's been around for quite a long time. So it's really about getting computers to do useful things with images. So machine learning is going to be another kind of one of the main topics that we kind of cover today. And again, this is probably familiar to a lot of you, but it's something we'll kind of go through in the workshop. But essentially the idea with machine learning is that you're trying to develop some kind of process in which an algorithm, so I'll leave it a little bit vague what that is at the moment, but some way in which a computer can improve at a particular task without being kind of directly told how to do that task, and instead being provided some data which it can use to kind of learn how to complete that task. And then the kind of final thing that I kind of wanted just to give a very quick definition of is deep learning, which is a kind of subset of machine learning that we'll kind of use in this workshop. So I'll give a very kind of quick introduction to the use of computer vision in humanities, which is the kind of focus of this. And I guess there's kind of a few main ways in which computer vision has already played a role and is increasingly playing a role. So one that we're not going to cover really at all today, but that's very important, is optical character recognition. So probably most of you have come across this. So it's the kind of process in which you can turn an image of a text into something that's machine readable. So example of that is if you kind of scan a document and put it in Google Docs, it will often be able to kind of find what the words in that document are, and then you can kind of search for those words. And in the kind of context of libraries, this is often the kind of way in which large collections are made available in a kind of machine readable format, because the kind of process of manually typing in all of that text would just be impossible to do at scale. And the reason I mention this is because even if you have no kind of interest in computer vision itself, this kind of optical character recognition, particularly if you're working with historical material, will often have an impact on, you know, what you can do with the text that comes out of that software. So it's kind of important to be aware of that background of how that material became kind of machine readable text. So I'll just give a kind of very quick overview of a few different projects from the humanities that are kind of increasingly using computer vision. So this first one is a kind of paper that talks about what they kind of term the visual digital turn. So within the kind of digital humanities, there's been, I guess, quite a heavy focus on textual material in the past, you know, primarily because that was, I guess, the material that was slightly easier to work with digitally. But increasingly, there's more and more researchers who are also interested in trying to use computational methods to ask humanities questions with visual material. So I think I will just mention these two projects quickly as a kind of examples of that. So one is this project called the Distant Viewing Lab. And this is a lab, a research group that focuses on computer vision for various humanities applications. And they've got a kind of range of software and papers. So one example of some of the work that they've done is using these computer vision methods to kind of analyze these two network era sitcoms. I'll try and find a nice picture in here, but basically what they're trying to do is see how some of these modern computer vision techniques can potentially be useful for doing kind of what would be predominantly kind of visual studies work. And I guess part of their interest is in seeing how that work can be in some ways made more accessible to humanities researchers by getting computers to do some of that heavy lifting. So one of the things that they do in this paper is look at who is speaking more in particular scenes, or how shots are set up. And these are the kind of things that people working in film studies might have done at kind of manual level before. But a lot of these kind of computer vision techniques allow you to do that at scale in a way that kind of makes it accessible to do that across much larger amounts of material. And the other project that I will kind of quickly mention is the one that I'm working on. So yeah, this is the Living with Machines project that I mentioned briefly. And as I said, it's a kind of digital history project. And the main goal of the project is to understand the impact technological change had on people during the Industrial Revolution. And to do that by applying data science techniques to large-scale digital collections. So primarily that's been digitized newspapers. But over the kind of, the life of the project, we've also turned to work more with visual material. And I won't go into too much detail about that. There's a kind of blog post that introduces some of that work, which has been to do with Ordnance Survey maps. So I don't know how many of you have seen this website before. So this is from the National Library of Scotland, who have this kind of amazing collection of historic Ordnance Survey maps. And what we've been doing on the Living Machines project is trying to see how computer vision techniques can be used to work with these map collections at scale, to kind of automatically detect features in those maps in a way that would be kind of difficult to do manually because of the scale of this collection. So I won't say too much more about that. So I think that's it for my slides. The only other thing I will kind of quickly mention is that the material we're working through today is based on a kind of under review lesson for the programming historian. So I don't know if any of you have come across that before, but it's an online journal focused on developing tutorials aimed at humanities researchers. So the kind of notebooks that we're working through are quite text heavy because they are originally intended as a kind of written tutorial. So that's one of the things I'd be quite keen to get feedback on, is how that kind of translates into a workshop format. So I'm kind of happy to get fairly brutal feedback if that doesn't work, but we'll see how we get on there. Yes, I mentioned all the materials for this workshop are in this GitHub repository. And I think what I have done in the past when I've done this in person is that people have kind of followed along on their own computers. So you're very welcome to do that. If you kind of go to these links, you should be able to open this up and you'll probably be asked to sign in to your Google account. But other than that, you shouldn't have to do anything to get this running. Depending on how you're kind of set up on your machines, though, it can be quite hard to kind of switch between watching someone else and doing stuff on your own screen. So yeah, it's up to you if you want to kind of follow along, or if you want to just kind of see what I'm doing. It's kind of down to your personal preference. But I think maybe what I'll start by doing is explaining what this is for those of you who haven't come across Jupyter Notebooks before. So I'll just give a kind of very high level overview, but if people have questions, then you're very welcome to ask, and I'll do my best to kind of address those. So as you probably already see, this kind of Jupyter Notebook thing, and in this case, we're basically using a Google branded version of that with some slight differences, but much of it is quite similar. And what this kind of Jupyter Notebook interface allows you to do is to combine kind of text, which we have quite a lot of in this notebook, with cells that are kind of made up of images, but also code cells. So the idea with this kind of Jupyter Notebook interface, I guess, is that you can not only convey information to a computer on what processes you want the computer to do, but also try and convey that information to other humans. So this is the kind of idea of literate programming, where the code is kind of put in relationship to some text and doesn't kind of stand alone. And this is being kind of used quite heavily in a lot of data science applications. But this is also an area that I think libraries and digital humanities projects are also increasingly trying to make use of these notebooks as a kind of way of making some of these techniques and information more accessible. So in terms of interacting with these notebooks, as I said, when you first run a cell, and I'll show you how to do that, you'll probably be asked to log in, but because I'm already logged in, that probably won't be needed. The only other thing that you probably want to change if you're going to follow along to this is this thing called runtime type. And I'm going to be a little bit vague about all of the reasons behind this. This is one of the big reasons we're using Google Colab, is that they give you access to something known as a GPU. So this is a graphical processing unit. So basically this is a kind of bit of compute that most of your laptops or computers probably won't have available, but in kind of air quotes, Google gives you this for free. So that's one of the nice things about this Google Colab environment. And the reason that this is quite important is the kind of type of machine learning we're going to be doing today, the deep learning based computer vision, will work much better if you have one of these graphics cards available. So if you do want to run this notebook, it will definitely be a lot quicker if you enable this. So all you need to do is kind of change this drop down to say GPU and then hit save. So yeah, this Jupyter Notebook interface, the idea is that you can kind of run each cell independently. So you'll probably get this same message when you first run it, and you can just click OK to that. So what's happening when you click this kind of play button is whatever code is in this cell gets executed. So the computer runs that bit of code, but all of these other cells don't run until you kind of tell them to. So that can be quite nice as a way of also kind of gradually building up what you're trying to do with your code. And also as a kind of teaching aid to kind of be able to go through these programs in a kind of more step-by-step way. So essentially this first line is just setting up some data that we're going to be working with in this tutorial. So I'm going to kind of skip over these quite quickly for now, and we'll kind of come back to those a little bit later. Check that's there. So I'm just going to quickly pause there to check if there's any questions so far. So there's a question about whether you can do this in Jupyter as well. So this notebook should work the same in kind of normal Jupyter environment as well. The only thing that will be different is that you will need to be kind of responsible for installing the packages that are required for this notebook. But I can kind of share some instructions for doing that at the end of this workshop. Okay, there's a question about our files downloaded and saved somewhere. Yeah, so I should have kind of probably explained this a little bit more. So what this line of code here is doing, and I'll kind of very quickly explain. these Jupyter notebook / Colab notebooks allow you to kind of run primarily Python code. One of the kind of nice features that you can do is if you have this exclamation mark, you can also run bash code, so what you'd run on a command line. So if you're kind of familiar with bash, then that's quite helpful. So this line is using Git to clone this repository, which is the one we have here. And basically we're using that as a kind of way to download some data. So what this line basically does is says to Git to grab this repository, which is just a bunch of folders really. And then if you click on this little icon on the side, you'll see some files, or some folders rather, that Google Colab has available to it. And by default, you'll always have this kind of sample data, which is just some data Colab provides. So these are some kind of just some data sets that you can kind of play around with. And in this case, we have this kind of program historian folder, which contains various different images. And in this case, the kind of data set we're going to be working with is this ads data. And I'll kind of go into how that's structured a little bit more later. But I guess this is one of the slight annoying things about Google Colab, is that the process of getting data into this environment can be a little bit annoying at times. But often if it's available somewhere online, then doing this kind of git clone or downloading it in some way is the kind of easiest way. You can also upload data via this upload thing. But that, if you have kind of large data, that can get a little bit slow to do. So yeah, I'm gonna kind of, as I said, this notebook has an awful lot of text in because it was originally intended as a kind of written document. I didn't take it all out because I thought that would be a little bit annoying, but what I'm going to do is just try and skirt over the bits where I don't think it's important to kind of dwell on things. And a lot of this is kind of setup information, which we don't need to worry about for this workshop. So the only thing that I'll kind of quickly mention, and then I'll kind of try and get to the kind of more important bits, is that the structure of these notebooks is maybe slightly back to front. And what I mean by that is the kind of first notebook that we're going to be going through basically jumps into doing a lot of things without too much kind of background on what it is we're doing or all of the kind of theoretical underpinnings. And I guess there's a bit of a debate about whether that's a good idea or a bad idea. So again, that's something that I'd really appreciate feedback on. But I guess that the aim of doing that is to kind of start from these fundamental high-level overview of how everything kind of works, and then following that kind of dig into some of the more the kind of more low-level details of what's going on underneath, as it were. And the other reason that I think this is quite useful is this kind of deep learning, machine learning domain. It can be quite, I guess there's a perception that it requires a lot of either engineering or maths expertise. And depending on what you're doing, that could be true. But I think there's also a lot that can be done at quite a high level without kind of all of that prerequisite first. So I think it could be quite useful to kind of start out from a kind of practical, goal-driven approach to doing some of this work, and then filling in some of those theoretical details as they're needed, rather than kind of doing a lot of kind of theoretical background, which might not actually make that much sense until you kind of get into the topic. And then the other thing that I'll maybe just mention briefly about this kind of line here is, as I kind of mentioned, this is quite a high level overview. And the goal is really to kind of see how these methods can be useful in the kind of humanities domain. So that does mean that the kind of actual computer vision methods that we kind of introduce in this are fairly basic. But I think a lot of the kind of interesting parts around computer vision in the humanities isn't just about the kind of technical bits, but the broader context in which you try and use these techniques and how they kind of relate to research questions and things like that. So that's quite a big focus of this that hopefully will make sense a little bit more as we go through this. So yeah, I'm going to give a very quick flying introduction to machine learning. So for some of you, this might be kind of very basic, but for those who aren't familiar with this, I want to kind of give a quick introduction to this idea of machine learning. So the kind of example that we quite often have is something like spam detection. So if we wanted to kind of build some kind of computer software that would detect whether a particular email had spam in it or not, there's various different ways in which we could do that. So one way might be to kind of look through a bunch of emails that are spam and a bunch of emails that are not spam, and to try and work out if there's particular things about those emails that are going to indicate whether it's spam or not. So one kind of fairly obvious way in which you might try and do that is to, pick out certain words that are usually associated with spam. So I won't kind of list those words because they're probably all fairly crude. And then to come up with some kind of rules-based approach where you kind of tell the computer to look through all the words in an email, and then if the number of words that you have kind of identified as being likely to be spam words is more than 10, then you kind of mark this email as spam. So that obviously could work very well for certain problems, but I guess that the thing that's probably already obvious to you now is for a problem like spam email, this can quite quickly become a very kind of difficult process to maintain for a few different reasons. So one thing is just that the words in this kind of spam words thing could just change. So the people writing these spam emails will probably quite quickly work out, okay, this particular word's being filtered, so I need to swap that for another word. And then what you could end up with is some kind of, very kind of difficult problem where you have to keep updating these words over time because they keep changing. But I guess the other maybe more important issue that you could have in this is that depending on the context in which these words are used, you also might be labeling emails as spam that aren't. So actually writing the rules to kind of indicate whether a particular email is spam or not becomes quite difficult to do as a human, to kind of both to identify what those rules are and then kind of to write them down in some kind of computer program is quite tricky. And I guess the probably the answer that you've already will know about is that a lot of people then turn to this machine learning approach instead, where the idea is that instead of telling a machine the kind of rules that it needs to go through to identify whether a particular email is spam or not, instead it's shown lots of examples of spam emails and lots of examples of non-spam emails. And you kind of set up some kind of process in which the computer program learns from that data how to identify spam or non-spam emails. And in that way, you're kind of making your life slightly easier because what you have to do is just provide the examples. And this kind of process of learning these patterns is done by this algorithm. And we'll kind of get back to what this means a little bit later, instead of you having to kind of do it by hand. So this is an example of supervised learning, which is the kind of machine learning we're going to be focused on today. And that's the kind of branch of machine learning where basically you have some data and some labels for that data. And what the kind of process is trying to do is to come up with some way in which a model or an algorithm can take some input data and correctly apply those labels that you've previously shown it. So that's kind of the very crude introduction to machine learning. And I'm going to kind of jump into the kind of first example of doing this for images. So you might have already seen in the repository that we're going to be working with these images from historical newspapers. So if this link works. So this is a project from the Library of Congress called the Newspaper Navigator. And I don't know how many of you are familiar with the Library of Congress, but they have this collection of digitized newspapers called Chronicling America, which is a kind of massive collection of newspapers, primarily from America, but also other places. And I think this was last year, there was this project called Newspaper Navigator, which basically took some annotations from this other project and used that data to extract visual content from newspapers. So you can kind of see this example of this image here, that you have this kind of image of a newspaper page, and what this project was trying to do is to find all of these different visual components of the newspaper and then both extract and put those into various different categories. So we're not going to kind of reproduce this kind of process today, but we're going to use some of this data, and in particular there's this data set which is kind of derived from these advertisement images. So this is what this data basically is, a sample of images from this Newspaper Navigator data set, and I can hopefully open one of these. And you can see that, yeah, this is a kind of extracted advert from a newspaper. And yeah, the reason I kind of give a little bit of background about this is that I guess there's some particular issues that come up when working with historic material that we'll kind of get back to a little bit later on. But one of the other things that I think is kind of important to really mention about this, which again we'll cover in more detail, is that the kind of data that we're working with is already the output of some previous machine learning that someone's done. And as you probably already know, machine learning is almost never 100% accurate. So that's one of the things that we have to be aware of if we're kind of working with data that's been output from some kind of previous machine learning projects. So the kind of first application of this kind of image classification task we'll look at is, you know, it's fairly basic in some ways, but hopefully I think it gives some sense of why this kind of computer vision based deep learning can be so useful. And the kind of task that we're going to try and do is basically, with this folder of images of adverts, we're going to try and place these images into one of two categories. And those categories are basically an advert that has some kind of illustration. So, for example, this one has this kind of image here of some coffee. Or to say that this image is just text only. So obviously there's other labels that we could apply to these images, but we're kind of starting with this one as a kind of example, and basically seeing whether we can train this computer vision model to distinguish images like this from images like that one, which just have text only. So this is the kind of the goal we have. And I guess the other thing that, yeah, maybe I just kind of mention to kind of go back to the spam example. Even though this task seems quite simple, to actually write some rules by hand to distinguish images that look like this from images that look like that will be quite difficult to do, which is why this kind of computer vision based approach might work a lot better in many ways. So I'll kind of skirt over some of this stuff here, but I will kind of pause here for a second and hopefully you can read that. So in this kind of in these notebooks, we work with this FastAI library. So within Python, if you're not that familiar with Python, you have this kind of ecosystem of libraries, which are basically bits of code that other people have written to do various different tasks. And I guess this is one of the reasons why Python as a programming language is very popular, because there's a kind of very rich ecosystem of these libraries for doing, almost anything you can think of, which can make it, quite easy to do particular tasks compared to having to kind of come up with everything yourself. And so one of these libraries is this FastAI library, which is a kind of a library aimed at helping you do deep learning based machine learning. And there's a few reasons why we kind of use that in these tutorials. So one is that this kind of FastAI library is designed to make this machine learning process quite accessible. And a lot of the focus of this FastAI library is to kind of make these methods accessible to kind of domain experts. So people who work in a field that's not kind of computer vision research or computer science, but work in a field where computer vision might be very useful for doing a particular task, but isn't the kind of main focus of their work. And yeah, because of that, it hopefully makes this process more accessible. There's also other kind of libraries available that all kind of have pros and cons. So there's not anything in here that's particularly tied to this library. It's just the one we happen to kind of use here. Basically, as I kind of mentioned, we'll go through this process very kind of quickly, and then we'll kind of circle back to look at that in more detail later on. But in this kind of FastAI approach, and I guess more generally, once we've kind of defined the problem we want to tackle, so in this case, predicting whether an image has this advert or is text only, the kind of main steps, and I guess is assuming that you already have the data available with labels, will be to kind of load the data, which sounds straightforward, but sometimes can be, a kind of quite a big hassle. Create some kind of model, and then train this model. So we'll go through these steps very quickly here, and then we'll kind of circle back to them. So I'll explain what each of these cells is doing a little bit, but I won't kind of go into too much detail. So this cell here is basically the way in Python that you kind of import from one of these libraries. So in this case, we import this vision part of this FastAI library, and that kind of gives us all of the tools that we need to start doing our computer vision work. The other thing that we import here quickly is this matplotlib library, which is used for plotting within Python. So we'll see that a little bit later on as well. And I guess coming back to this process of loading the data, depending on how your data is stored, as I kind of said, this can be quite a painful process, but quite often when you're creating data or you're getting data for some computer vision task, a lot of times it will be stored in some kind of CSV format. And often what that will look like is you will have some kind of column with files pointing to particular images, and then you have a label associated with that image. And within this FastAI library, there's various different ways in which you can load images or training data. And for the images, they all kind of sit under this thing called image data loaders. And as you can probably guess from this name, this one is for working with images and data stored in this kind of CSV format where you have a file and associated label. So basically what we need to tell FastAI is where this folder is that has our images. So in this case, this kind of adds data / images folder that has all of these advert images. We also need to tell it the column in the CSV which contains the labels. And then the only other thing that we need to do in addition is to do this thing called resize, which you can probably guess from the name, is to resize all the images to a standard size. So what this kind of looks like, as you can kind of see line by line, basically this is just building up all of the information that this FastAI library needs to know to be able to kind of grab the images and labels from this folder of images and this CSV file which contains the labels. Sorry, that keeps jumping around. So once we have kind of told FastAI where all of this information lives, there's this kind of handy method within the FastAI library that allows you to kind of look at the data. And I guess this is one of the really kind of important things to do, both with computer vision, but with machine learning more generally, is to kind of keep coming back to your data and your labels. Because obviously, if you're approaching these problems as a kind of automatic thing where basically the goal is to train a model from this data, whatever you give this model as data is going to affect how well that model works and whether it does what you want it to. So in this case, it's quite useful first to check that these labels and these images kind of match up how you expect them to. But I guess the other thing that you might also start to notice here already is that some of these images look, a little bit funny. And you can probably guess already, but the kind of way in which these images have been extracted from these pages, they'll be in all sorts of different sizes and shapes, and often they'll be quite long because the way newspapers are primarily arranged is in this kind of column format. So what that means is, because we've done this kind of resize thing that just squishes everything to this kind of 2 by 224 by 224 pixels, some of the images start to look a little bit strange. So for now, we'll kind of ignore that, but we'll kind of come back to that and see if that's a problem later on. But we've kind of hopefully confirmed that these labels kind of match what we expect based on images. So that's kind of the loading the data part done. So the next thing that we kind of need to do this kind of fast AI approach to building a machine learning model is to actually create this model. And again, I'll be a little bit vague about what this means here, but basically this model is some kind of system that can learn from this input data that we've just created up here. So we'll kind of explore that in much more detail later on, but within FastAI, to create a model that's, in this case, this convolutional neural network, and again, I'll kind of keep saying this, but I'll come back to what this is a little bit later on. So this is essentially a particular type of machine learning model that's particularly good for working with images. And within this FastAI library, the way in which we kind of create one of these models can be quite straightforward. It can also become much more complicated, but in this case, basically what we need to give FastAI is the data that the model is going to use as training data, and then tell it what type of model we want to use. So just giving it those two things will already be kind of enough information to create one of these computer vision models. But usually we want to get at least one more bit of information. And in particular, what we'll almost always want is to pass in some kind of metric that we'll track during training. So this is some kind of score that gives us a sense of how well our computer vision model is doing at the task that we've asked it to do. So for now, we'll pass in this kind of accuracy metric, and again, we'll come back to explore this topic in more detail later on. And what we do here is, just to kind of give a very quick overview, is this is a kind of Python function. And this function, basically, we need to tell this CNN learner thing, these kind of 3 bits of information that I mentioned here. So the first is this ads data, which is basically what we created here. The second thing is this kind of ResNet 18, which is the type of model that we're going to use. And then we just say, for the metrics, please tell us what the accuracy of this particular model is. And we store all of that inside this thing called learn. So we could call this something else, but this is just the name that we kind of give all of this here. And again, as I will keep saying, we'll get back to what this little downloading thing is in a little while. But for now, we've basically got everything set up with enough information to kind of start training this model. So what we've done so far is basically set up everything that's required for this training process. But we haven't actually kind of trained the model yet. We've just told FastAI where the data is and what kind of model we want to use. And the training process is this kind of process in which the model learns, in air quotes, how to predict the labels from the data we've given it. And there's various different ways in which we can kind of train models. And, you know, this is a whole area of research. But FastAI gives us a few kind of methods to do this training process with. And in this case, we'll use this kind of fine-tune method, which often works quite well without too much fiddling. And the other thing that we need to tell it is how many epochs to train for. So that's this number here. And basically what that is telling FastAI is to kind of go through all of this training data 5 times. And you'll see in this case, it's actually 6 times because of how this fine-tune thing works. So I'll press play on that. And again, this point here, I think, is probably worth dwelling on a little bit. This thing about how much time the model takes to train. So I guess this is partly why we had this kind of discussion about the GPU, was because this process will be much quicker if you have that available than if you don't. But what you're probably already getting a sense of is this process is not really taking that much time at all. And in this case, that's because the amount of kind of training data we have is relatively small. So the number of images in this folder isn't too large. I mean, you could scroll through all of these and look at them quite easily. But the other thing that kind of point out is that you can see that this accuracy score, starts to go up, and you can also see it jumps around a little bit. But we end up with around 96% accuracy, and this took basically a minute to train. So yeah, I'll probably bang on about this point quite a lot, but I think this is one of the I guess key messages for people who haven't used these methods before. I think there can be a perception that all deep learning and all machine learning requires huge amounts of compute resources, huge amounts of data, and takes a very long time to train. But you can see here we've already got a pretty decent model that's getting a lot of the examples right, with relatively little time involved in training that model. So I think that's kind of where I'll maybe stop for now, and then we'll kind of jump into what's going on in a little bit more detail in the next part. Are there any kind of questions at this point? So why it has this 0 here or this 0? Yeah, so I guess this is the kind of this fine-tuned thing here. So this is kind of, I guess we'll get back to this a little bit more detail, but basically what this fine-tune method does is it trains the model for one epoch with all of the layers frozen. And again, I'll kind of get back to what that means a little bit later on. Yeah. And then it unfreezes the layers. So yeah, I'll leave that a little bit vague at the moment. And for anyone who's wondering why it starts from 0 and not 1, this is just a computer science thing where, most languages start from 0. Are there any other questions? There was one about organizing or preparing image data in a certain format. So I can say a little bit more about that at the end, but I guess, it really depends what you're trying to do, and also how you're, how you're going to be working. So quite often, this kind of format of putting things in, this CSV. I guess this tends to be quite a common format in which you see this, probably, for a few reasons, partly because it's quite easy to, produce this kind of data without too much bother, but also it's fairly kind of easy for other people to pick up data organized in this structure. The other format that you quite often see, and I'll try and find an example of that during the break, is that you kind of organize things in this folder structure where you have each label represented by a folder, and then all of the images inside that folder belong to that label. But yeah, this really depends a little bit also whether you're going to be working with other people or not. And I guess like how much you're going to be labeling. So some of these kind of tools for annotating machine learning data can take quite a long time to set up and be quite involved. So that might only be worth it if it's kind of a bigger project. So often if I'm kind of doing something quite basic, just to see if something works, I will just put images in folders and kind of do that as a starting point, because it's quite easy to kind of do without kind of setting anything up. So yeah, this, what does the accuracy mean? What is the program trying to assess? So yeah, maybe I didn't explain this very well. So it seems as though the only input data is the CSV file and not the images. So yeah, I guess, yeah, this image data loaders from CSV, basically this CSV is mainly used to make the link between the particular image and the label that it should have associated with it. So if I show you this kind of first row, you have this, yeah, these file names are a little bit strange, but this just represents one of the images in this folder. And what this kind of image data loaders thing does is it kind of, this path is to this top level folder. And then we also tell it that all of the images are stored inside this images folder. So as input to this kind of model, basically the FastAI library prepares this data to associate this particular image with this particular label. And this accuracy metric is basically quite a crude measure that we often use at least as a kind of starting point, which is, you know, how many times it got things right compared to how many times it got things wrong. And we'll kind of see why that doesn't always work a little bit later on. But yeah, this 96, you can kind of just see that as 96% of the time, this model correctly predicts whether an image is an advert with an illustration or an advert with just text.